Okay, so for question 4, they only asked for the value of x in 4.3, but you're actually going to calculate this quite easily just by looking at the second, the first difference, and then the second difference. So that's actually what I did, and then I read actually. So if you look from -9 to -2, to 3 and 7. Right, that is from -9, sorry, to -6. We are adding 3, then we're adding 7. All right, obviously we didn't know what x was originally, so we couldn't hold this one straight. Then you can see that all 3 to 7 are adding 4. Right? And I think in the question they said it's a quadratic sequence. So we know that if the first, second difference is 4, then that second difference is also going to be. Right? So using that, we know that to go from 1 to 8, we will have to add 7 more than 4 more than 7. Right? So the time the second difference has to be the same. So that's where I got that 11 from. And then if you do it like that, you can actually see that x is 12, right? From the start, after all the complicated stuff that they did. So I'll talk through the different, like the purple stuff that I did up here, which I had to do because of the way that they asked the question. But if they just gave you this number pattern and they said, find x, you actually could have just done it by looking at the numbers. So I'm just going to say again, from -9 to -6, you're adding 3. From -6 to 1, you're adding 7. So from between 3 and 7, the difference there is 4. They told us that it's a quadratic number pattern, so we know that the second difference has to be the same number every time. So the second difference is also going to be 4, meaning that from 7, when you add 4, you're going to get 11. Right, so if we know that our first difference here is 11, then we can get x just by saying 1 plus 11. So x is then 12. The way that they structured the question was quite complicated and unnecessary, I felt. So they asked for the second difference first. You could just look at your first difference and then the second difference is 4. Then they asked for the second difference in terms of x, right, which was difficult to do. So that's what I did in total up there. Right, so maybe your first difference is actually a term minus the one before. So in that formula, remember that 3a plus b equal to, it's not really at play here, but I'm just using it as an example. That's how we wrote that formula down, right? We said 3a plus b is equal to the first difference, which is second term minus first term. So to get the first difference here, so in order to get your second difference, you have to first get your first difference, right? So we're going to do that. So here, the first difference would be x minus 1, doing it in terms of x. The first difference there would be 27 minus 8. Always a term minus the one before to get that difference. So these two first differences, right, x minus 1 and 27 minus x, when they're then asking for the second difference, again, you're going to take that one minus the one before, which is so complicated. So 27 minus x minus x minus 1, and that is actually what you have to do in order to get the answer to 4.2. So to get the second difference in terms of x, you have to get your two first differences in terms of x, and then get the second difference from there. But like I said, it's so complicated, and in the test, for example, we won't force you to do this kind of question in such a difficult way. I'm sorry that I didn't realize that it was so difficult until I did it myself. Or just do you guys understand what I mean by actually getting x is easy, but they force you to do it in a complicated way, like that. In terms of x. So then 4.3, they asked for the value of x, but I think that they say hence or something. What they wanted you to do was to then understand that your second differences are equal, right? So if your second difference is 4, but it's also 28 minus 2x, then you can put those two equal to each other in order to solve them. So that's what they wanted you to do in the memo, but you could have just worked with the numbers and just gotten an answer of 12 for x, like I explained to you. That would have been fine. Then for 4.45, they were now asking you to calculate Tn, and then from there term 9, I think. All right, so and they actually just said find term 9. Oh, so I just thought maybe some of you just carried on counting. It would have been fine if you just went You just carry on counting thank you until you got to term 9. That's okay. It's not so many more terms because you already have 5 here. Right? So if from 27 you added 19 and then 23 and then 27, you could have done that. But the long-term method, if you define your TN formula, so A is your second difference divided by 2, 3A plus B is your first difference, and then A plus B plus C is term 1. Right, so that's what I did. I calculated TN, and then to get term 9, you just put 9 in the place of it. But like I said, if you just count it on, did anyone try to do that? If you want to count on, bottom the same answer. If you just did that, that probably would have been less work. That's finding TN. Right, then they wanted us to determine which term in the number pattern is 397. So again, same as what we've always done. If they're asking for what term it is, you're going to take that number and make it equal to TN. So here now I'm in 4.5. If you didn't calculate TN in 4.4, you would have had to do that here. So it's a bit of a practice there. All right, so your TN make equal to 397. Move it over, solve for N. Again, just like always, you're getting 2 answers, and the one that's either negative or fraction or both doesn't affect it. Okay, so this actually isn't such a difficult question, it's just the way that we set it out in the textbook. But then, number 5, so let me show you 5, I think you have to do 5.1, 2, and 3. And guys, we're finishing with number patterns today, so I'm going to upload this whole document in PDF when I post it later to the classroom, so if you just think about it. Okay, so they wanted us to find A and then the value and then TN, so the value of A here and then T. So in order to get A, you need to check, okay, what am I doing? I'm adding 7 each time, so that's quite easy. So from 28 to A, you must also add 7. Right, so that is why A is 35, 28 plus 6. Right, if you just continue with that pattern as it is. And then because we have a constant first difference, it's a linear number pattern. So we know that the formula for a linear number pattern is that one. A is the first term, which is 7. And then the difference is also 7. And then we multiply that out, simplify, and answer is actually 7 in. Okay, so that one was quite simple. I'm going to do that. The next one was also just a normal linear number pattern. We were adding 5 each time. All right, so there you're adding 5, and then you're also adding 5. So to get B, you would again have to add 5. All right, so B is in 3.5, which is 8. We're using the same formula. It's again a linear number pattern. We have a constant first difference. So A term 1 is negative 7. D, the difference is 5. We multiply 5 into that bracket. And then you could also written it as negative 12 plus 5 in, that's fine. That was really fine. We have the final answer. Okay, now 5.3. That was a difficult one. And the reason for that is because at first glance it looks like a quadratic number pattern, but it's actually not. So I did the calculation as if it is a quadratic number pattern, and then when I checked, I saw that it actually doesn't work. Okay, so let's just go through my thought process here. This one, you can see that I've highlighted it here. This is like, it's not a trick question, this is like a problem solving question. So maybe add that just to the question there. This is actually a number pattern that we don't have a formula for. Okay, and you could get something like that in the case for exam. So you're maybe multiplying by the same number each time, or where they're all cubes or all squares or something like that. Okay, so guys, at first glance, if you look at this, you see that from 14 to 28, I'm adding 14. Then I'm adding 28. Right, or you could maybe possibly a dozen each time, right? Maybe some people notice that. Starting with 14, 14 times 2 is 28, and 28 times 2 is 56. right? If you're looking at it that way, guys, it's actually easier because what is 56 times 2? 112, hey? And will it work then if you carry on? 112 times 2 is actually 224, hey? So actually my thing that I wrote here at the bottom of C now is a bit more complicated than I need to be, okay? So if you are working on, if you are saying that this is a quadratic number pattern, then that would be what you are doing, right? You would say that this is your second difference. So here you would have to add 14 more, and there you would have to add 14 more. But guys, the thing is, you can't really decide that something is a quadratic number pattern if you only have one second difference. Because what is a quadratic number pattern? A number pattern with a constant second difference. So you actually have to have two second differences, right? Because this is what we had. We just had that, and actually not even this. Let me take this away. That is the information that we have, right? We could see that you're adding 14 to get there, you're adding 28 to get there, and then we don't know what C is. So we can't see what that third first difference is. Okay, we can see that we definitely have a second difference of 14 here. But guys, how can we say that we have a constant second difference if we only have one? Right? So you actually do need two. That's why in some questions where you only have one, they'll say in the question it's a quadratic. Okay, so let's write on the side here. We need more than one second difference. To say that it is quadratic. Okay, so that actually hasn't really come up before because all the number patterns that we've done so far have either been linear or quadratic. But that is quite important, guys. So you have to add that. If you can only see one second difference, then you don't know, thank you, whether the next second difference will be the same. Okay, you don't have to have that information. Because then when I did that, when I assumed, okay, let's say 14 is a constant second difference, and I added 14 to 28, that's where I got 42 from, and I then calculated the value for C, I just got 98. But then guys, if you add that same second difference to get the next one, you don't actually get 224. All right, it doesn't actually work. So that's why I wrote it here, just so that you can see that you could check it and it doesn't actually work. So we need to find a different type of number pattern. Okay, so I rewrote it here. Are we all okay with this being times by 2 and multiplied by 2? Right? And then we said, okay, if we see whether that pattern carries on, and we multiply 56 by 2, and we say that that's 112, then that does actually work. It does give us the next term again. When I multiply 112 by 2, that does give me 222. Okay, so guys, that's why they gave you the next number, so that you can actually check whether your pattern continues after that. Okay, now the difficult thing here, we can find C, right? That was the first part of this question. Calculate the value of C, so C is 112. But now the difficult thing here is we need to find our TN. And at the moment, we don't have a TN formula for when we're multiplying by the same number each. All right, and we could do actually the formula for that, which I suppose, I wonder. Okay, yeah. Let's do that. Because then we're going to have to struggle with trying to figure it out. If we are multiplying by the factor, we call that number a constant ratio. Put in brackets that is in R. So then this is the formula that we work with. You don't have to memorize this formula if you don't want to. You can kind of do it by inspection as well. But in case you're not keen on doing it by inspection, you can use this formula. Again, A is the first term, so that's quite nice. A is term 1 again. And then R is that ratio, that number that you multiply by. And then you're going to have the n minus 1 in your. And that's when you multiply. So you can quickly just, I'll show you how to do it by inspection as well, but if you're using this formula, what is your first term in this number pattern? Let's move it down. What was our first term there? 14, right? Okay, so we'll put that in 14. And then because it's AR, that actually means A times R. All right, so you can put the times symbol if you want, or you can put it in brackets. I'll show you now. What is the number that we're multiplying by each time? 2. So that will be the formula. 14 times 2 to the n minus 1. Or you can do it by inspection, which is something that you can fall back on maybe if you forget that formula. If we are looking at our number pattern, we need to, it is quite difficult to do it by inspection, but it won't always be that difficult. Sometimes you can see it quite easily. But if you are multiplying by 2 each time, you're definitely going to have a 2 in your formula, okay? And it's always going to be a 2 to the n as well. So your formula might be a bit different even when you're doing it by inspection, but it will get you to the same terms always, so don't worry about that. But you will definitely have a 2 to the n. That's what I can tell you. If you're multiplying by 2, you're going to have a 2 to the n, like we have here. We have a 2 to the n minus 1. But there is another formula where you just have a 2 to the n. So if you have 2 to the n, right, let's think. What is n again? What does n represent? N is always the term number. So if I have 2 to the 1, right, because for my first term, my term number is 1. You guys agree with that? So 2 to the 1, that's 2. What does I then do to that to get 14? What does I do to 2 to get 14? Times by 7. Okay, let's see if that works for the other terms as well. For my second term, what is my n value? If it's term 2, n is 2. So what is 2 to the power of 2? 4 times 7 is 28. Okay, next one, let's see. Term 3, my term number is 3, so n is 3. So what is 2 to the power of 3? 8. And it's 8 times 7, 56. Yes. Okay, so you can do it like that, times by 7 off. So maybe we should write a little note here at the bottom. So this 2 is the number that you are multiplying by. So maybe that's easier than actually remembering the formula, because then you just need to remember whatever you're multiplying by, you're going to take of n. All right, so number that you are multiplying by. And then you need to figure out, if you have that 2 to that number, what must you still multiply by to get the actual term? Okay, so this times 7 is like the by inspection. But this would be problem solving type question, right? So if you get something like this, it will really be like the difficult question on the paper. And yeah, you probably won't get something like this, to be quite honest, and focus more on the other types of numbers. Okay. Any questions on this? Now, guys, these two formulas are different, right? But you can actually write this one in that way, because 14, you don't have to write this down. I just want to show you. 14, you can write as 2 times 7, and then you have times 2 to the n minus 1. Right? And what do you do with exponents when you have the same basis? What do you do to the exponents? You add the exponents together. So then here you will have your 7, and then you're going to have your times 2 to the 1 plus n minus 1. So that 1 minus 1, those are going to cancel each other out. So then we left with 2 to the n. All right, let's look at this one, the picture one. So this was quite difficult, I think. Because you have to do lots of calculations on that blue. It doesn't look very nice. Let's see if I can just change the color here. It's a bit bright. Yeah. Okay. So guys, for the first one, I think we did talk about this number of tiles in the base of the structure. Remember, the base is actually the red tiles, right? Because they said that they flipped the structure over. So for the first 3 figures you could count, they gave us those 3. There was 1, and then there were 4 tiles, then there were 9. And then you have to carry on with that number pattern to get the next 2. Okay, so I'll show you my working here to get that. So here, again, in this case now, we kind of have to assume that it was a quadratic number pattern. But guys, I want you just to look at this number pattern now and see if we can actually find out Tn by inspection, instead of doing that long calculation. For figure 1, you can see that that is 1 squared. For figure 2, 4 is 2 squared. For figure 3, what's 3 squared? 9. 4 squared is 16. 5 squared is 25. So guys, actually, without doing that long calculation of getting your an squared plus bn plus c, you can actually see that for this number pattern, what we're doing every time is we are squaring the term number, the figure number. Right? I'll write it in black there. 1 is 1 squared. 4 is 2 squared. Wait, let me do that. Let me just make this thinner. That is 1 squared. That's 2 squared. 3 squared. 4 squared. And then 5 squared. So do you guys see why I'm saying that my term n is going to be n squared? It's always the term number that we're squaring to get the actual number in the pattern. Right? So that was one that you could actually have done by inspection. Or you could have done the whole long calculation. There we go. And you would get n squared from it. So you actually end up with a being 1, b being 0, and c also being 0. Right, so this one can be done by inspection. Or you can use the formula, you can always go back on that, but no, maybe I can save some time. You can try and look after that one. So the next one, this one is a bit this one is a bit more difficult to do the next one because I didn't even give it the third one, but this is the one that I was trying to count in class and then I got confused, okay? So this is where you have the vertical tiles. So all the lines that are standing up basically. Okay, so I tried to do this properly. We have 3 vertical tiles at the back. 1, 2, 3, right? 1, 2, 3. Then we have 3 on each side. Okay, so we actually have 12 tiles going around the shape. Then I decided to count down first and then across. Okay, so that I don't miss out on anything. So we're on 12. Then we have 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Yes? So that is where I got that 24 from. Then for the next one, guys, again, you could look at what another pattern is and you could have continued it, but you can also think what's figure 4 going to look like. Let's think about that. Figure 1 is just one cube, right? Figure 2, do we see that we have 2 in that row, 2 going across and 2 going up? Alright, in figure 3, we have 3 going across and 3 going up. So what's figure 4 going to be like? So 4 across and 4 up. Hey, so actually 16 boxes altogether. So I'm not going to try and do that now because I'll probably embarrass myself. But I did that kind of calculation in my head. I counted if I have 4 tiles at the back, 4 on the side, 4 on the front, and 4 going there, then that's already 16 tiles just on the outside. Right? Then you're going to have 4 going down, 4 going down, and another 4 going down. That's 12. And then the same across. 4, 4, 4. So another 12. So that is 40 altogether. Pretty sure. Yeah, that's calculated a couple of times. And then from there, you can actually see quite nicely that it is a quadratic number pattern. So when you have your 40, okay, you can carry on to get to your 60. And for this one, you did, I think, have to do a calculation. This one was a bit more difficult to define picture. So I did the normal a squared plus b plus c thing. A is the second difference divided by 2. 3a plus b is the first difference, which is that number there. Then you do your a plus b plus c turn 1. And then guys, remember it's c0, that just means that you don't have a c, but don't have a c. Okay? So it was 2n squared plus 3n. So that will return into. All right, and then for the last one, you didn't actually have to do any calculations for the last one. I did mention it in class already. If you look at, because they're saying the first row is the number of tiles at the top. Then the second row is the number of tiles that are standing up. So when they say the total number of tiles, that's when you add all of them together, right? The ones at the top and the ones that are standing up. So that's actually what I did. And if you look at the table and the values that we've already pulled in, you could see that. So the total number of tiles is going to be 1 plus 4 is 5. Right? If you look at the picture, that's so what happens. You have 4 tiles along the side and then 1 at the top. That's 5 over here. Okay, so you could just do that all the way through. 4 plus 12 is 16. 9 plus 24 is 33. 16 plus 40 is 56. So there you can see nicely that it actually works out, right? Because when you add these two numbers together, you do get 56. For the next one, 25 plus 60 is 85. And guys, then you can do the same thing with the two formulas. Right, so if you are realizing that every time you get the total number of tiles, you add those two together, you can do the same with the formulas. N squared plus 2n squared plus 2n is 3n squared plus 2. Okay, so this calculation, I'll just write it in there. Or you could have gone the long way around. You could have written this out as a number pattern and calculated A and B and C. It also would have worked. But it is quite nice to also find it. Okay, finance, let's go. Finance. Financial maths. Do you want to write finance or financial maths? It's up to you. Finance, okay. Finance. You can make that heading. It's a new chapter. What chapter is it? 60. Guys, this is the last section that we're doing before your exam. Finance is on topic 11. Yes, yeah. Topic 11, please. Chapter 11, topic 11. If you want to write that, you can. Okay, and for today, we are just going to revise the formulas that you've learned already. Some of you might have done depreciation, some of you might not have, but it's fine. It's not a big difference. Only difference is you use the same two formulas, the plus is just a minus. That's all. Okay. So the first heading, we're not going to talk about interest. We're going to just for now talk about simple and compound growth and decay. And that's the heading I think that they use in the textbook. Guys, I know we all tried and we're not list for math anymore at this point of the term, but this is going to save you'll take a 2 mark. Remember finance, you can take a 2 this exam only. So if you're worried about paper 2, which was analytical and quick graphs, then this is what's going to help. All right, these marks will boost those 2 topics. Okay, so simple and compound growth and decay. All right, so in the past, I think we just did simple interest and compound interest. Okay, same thing. When you are investing money, it grows. Okay, so that's the simple growth or compound growth. That's what we're talking about when your amount is getting more, basically. Okay, so our formulas. When you have simple growth, the formula is A is equal to P bracket 1 plus I times M over. I'm going to write down the 4 formulas and then write down what each of the letters represent because it's the same for all 4 formulas. All right, so simple growth, simple decay. Like I said, the same formula, the only thing that changes is that the plus is now a minus. Okay, there is another name for simple decay or depreciation. That's also what we also call it depreciation. So I'm just going to add here, or this is also called straight line depreciation. Okay, so we can have straight line depreciation, which is used for the ticket, then you can use that for it. If you do accounting, there's a different method that you use in accounting. You don't use this instant accounting, all right? But in math, the questions will be asked in such a way that you have to use this. In accounting, you just calculate the annual amount of use. Okay, then compound. A is equal to P bracket 1 plus I to the power n. And then when you're doing compound decay, all right, what the depreciation method is called as well. That is A equals P bracket 1 minus I to the power n. So the formulas are the same, it's just plus for growth and minus for decay, for decrease. Right, if they are talking about depreciation, they call this reducing balance. I'm just going to highlight these names. Okay, in terms of what these variables, vectors, what they represent, I'm just going to write that on the side because, like I said, it is the same for all four equations, all four formulas, which is quite nice. So A is the final value or amount, obviously depending on the context of the question. So if they're talking about like what's it called, an investment, then the amount in that account after like 5 years, what is it? That will be the final amount. Okay, so the amount after time has passed. But if they're talking about like population and they're saying that the population is decreasing, so at the end of 2030 we expect it to be this, that's going to be the final amount of people. Okay, so it's not always money. But that is what A is. A is always after a certain amount of time. So you can just think A is after. Right? Maybe that's a useful way of remembering, because sometimes it does get a bit complicated in terms of figuring out which one is A and which one is B. Okay, so A is always after some time has passed. P is the original value or amount. So if you're investing an amount, then that's the original amount that you're putting into the account. Okay, so that will be the value. Or you'll see when we're going to do some depreciation questions now. When you buy a car, it's worth a specific amount when you buy it. Right, so that is the P value, the original value. After time, the amount decreases, the value of that car decreases. So that will be A after say 5 years. All right, I is the interest rate. And that is always in a percentage. So far, we've only done annual interest rates, so like 5% per annum, per year. Tomorrow, we're going to talk about, did I see that tomorrow? What is going on? Oh, tomorrow's Thursday. Okay, I don't see right now. Oh, I'm getting confused. So tomorrow we're going to be doing interest rates that are like monthly or quarterly. All right, so far we've only done annual interest rates, so the same rate for 1 year. So we're going to change that up this year. But if they say, for example, 10%, you're going to use 10 over 100 for your I. Okay. Then N is the number of years. We've also only worked with number of years so far. From tomorrow onwards, we're going to work with number of months, possibly days, and so on. Okay, before now, we've only worked with number of years. Okay, so we're just going to practice using these four formulas now. In about 17 minutes, so let's see how many examples we can do. Are there any questions at this point, right? Yeah. All right, so you can write examples along. Okay, sorry guys, but this is going to be quite a bit of variety. So let's see. Okay. Ooh, sorry, I'm just trying to see which examples we should do. Okay, a piece of equipment That's the first question. Okay, guys, so, sorry. What we need to notice here is that we're talking about depreciation, right? So we're going to have to put that minus in our formula. And because they're saying reducing balance, it's going to be the compound one. Okay, so straight line is the simple one, and reducing balance is the compound one. Okay, we need to identify what they're actually asking us for here. We're saying calculate its original value. About which later represents the original value. To go back to our list. That's P actually, right? So we need to find P. So this is not just a straightforward plug into the formula and calculate. They've actually given us the after value. You guys see that? They're telling us that the value is 11,300 after 3 years. So the after value, so this is actually our A value that they've given us. Okay, they want us to calculate P. They gave us the interest rate, it was 9%, right? So that's our I value. And after 3 years, so N is 3. So they've given us all the values except for P. Okay, so that's what we're going to have to calculate. Because usually I just start by writing the formula down. And we need to remember that it's the reducing balance one, so it's the one where the N is the exponent of the bracket. And then we're going to put all the values that we have into that formula. So we have 11,000, so 11,303,57. That is our A value. Equal to, P is the one we need to find. 1 minus, now guys, for 9%, you can decide whether you want to write it in decimal form, or if you just want to write it as 9 over 100. Okay, I personally always write it as a fraction. There's nothing wrong with that. It's not a fraction that you have to simplify. Yes? So because they've said reducing balance times the compound. Okay, it's simple, it's straight line. So they have to tell you in the question. All right. Okay, so 1 minus, so guys, here instead of 9 over 100, you can write 0.09, but you don't have to. You can just leave it as 9 over 100. And your N value is 3. Yes? You can, yes, but then you need to write 9%. Okay, if you just write 9, you're going to lose it. Okay. So guys, yeah, there is a percent button on the calculator. You don't think it's on this silver one. Oh, I see. Okay. So yeah, so you can press 9 and then that bracket one over there. So shift and that one. And then it does actually calculate the percentage. But you have to remember that. Okay. I normally just put 9 over 100. That's fine. Now guys, if we need to get P on its own, this is what I'm solving for. Alright? Do we notice that P is in front of the bracket? I'm multiplying P by this bracket. Basically, I need to move this whole bracket to the other side. What's the opposite of multiplying by a bracket? Dividing by it. Okay, so that's what we're going to do. We're going to say here, P is equal to And you don't have to write the step down, but this is the first example. Please do write it down. 11,303,57 over, or you can say divided by that just to find your whole bracket. Alright, if you want to, you can calculate what this bracket is, right, in decimals. I'll just do that quickly. 1 minus 9% to the power of 3. So that is that in decimals. Right, but guys, then you need to keep that answer in your calculator and use the answer button. You can't now say, oh, that's 0.75. Okay, because that is rounded off. You are only allowed to round off in your final answer. So if you do that, right, you're going to have to, again, you don't have to write this down, but if you want to, you can. You're going to have to write 0.75 ... to remind yourself that you're actually not rounding that off. Okay, you can't now in the calculator type in 11,303,57 divided by 0.75. You're not going to get the right one. Okay, if you want to do that, you have to say 303.57 divided by answer button, please. Then it's going to take that whole unrounded value and you will get the correct answer, which is 15. Okay, so P is 15,000. Yeah, we're finding that one, guys. I'm just trying to see which one should I do. Okay, second question. We're going to quickly finish this one. Okay, again, we're talking about depreciation, right? We're saying depreciate, and now we're saying on the straight line method. All right, so straight line, that is the simple one, simple depreciation. Okay, so that's the formula that we're going to write down. A equals P bracket 1 minus I times N. And I've seen so many times that people are out of habit, I suppose, because you kind of lose focus for a second. Instead of putting a minus, they you put a plus there. Right, just be very careful that when it is depreciation, you have to put that minus there instead of plus. Okay, so now we need to figure out what is A and what is P. We are finding how long it will take, right? So we're calculating N in this case. So we're supposed to have all the other values. So they're saying calculate how long it will take an item valued at 30,000 Rand to depreciate to a value of 10,000 Rand at 8.5%. So that, what is the original value of this item? 30,000, right? So that is our P value, is 30,000. The after value, the value that it has after however many years, we're going to calculate that now. That is that's 10,000. Okay, so we have 10,000 for A equal to 30,000 for P, 1 minus our interest rate is 8.5 over 100, right? 8.5, you can write percent if you want to, times N. Again, we need to solve for N, so we need to move everything else systematically to the other side. Guys, before we start moving stuff in the bracket, we need to get rid of this 60,000. Okay, on the side, I'm multiplying the bracket by 30,000, so when I move it, I'm going to divide by 30,000. So what is 10,000 divided by 30,000? That's just a third, hey? You can type it into the calculator if you're not sure of that, that's fine. 10,000 divided by 30,000 is 103. So that is equal to 1 minus 8.5 over 100. And guys, I'm actually going to write the x next to that fraction. We can do that, right? If we have a number multiplied by a variable, it's like 3 times x, 3x. Okay, next up we need to move this 1. It's positive 1 on this side. When I move it, I'm going to subtract 1, right? So a third minus 1 is actually negative, yes, 2/3. That is equal to negative 8.5 over 100 n. Now to get n on its own, I have to divide by negative 8.5%. Alright? So what is that going to give me? Let's see. Obviously, you'll type that into the calculator, right? So you'll do negative 2 over 3 divided by negative 8.5 over 100, and we are getting 7.8. Okay, we're going to leave it like that. That's fine. Usually they say how you have to round for these values. But let's just say 7.8 years. Okay, and that is the end value. So they say to the nearest year, what would you say for that? 8. Okay. You can add that. Just do a squiggly equals and just say 8 years. Okay, but they do usually specify how you need to round. Okay, guys, I'm just going to give you 2 questions for homework. It's not a lot, it's just this depreciation stuff. Sorry that we didn't have class time now to work on it. It's exercise 1, page 240. 1 and 2. Okay, that's it. Thanks, guys. If it's packed up, you can go. Have a good afternoon.